Hi, we have the AP Physics 1 past paper 2023. We are discussing free response question section. In this question number 3, carry the 12 point. A small block of mass m naught is attached to the end of the spring of spring constant k naught attached to the rod on a horizontal table as shown in a figure. The rod is attached to the motor so that the rod can rotate at the various speed about its axis. When the rod is not rotating, the block is at the rest and spring is at its unstretched length L. As shown, the all frictional forces are negligible. In next part, there is a two different time at t is equal to 1 and t is equal to t2. What is showing that the time increase there, the distance from the axis of rotation has been increased. Okay. At time t1, rod is spinning such that block 1 moves in a circular path of the constant tangential velocity v1. The spring is stretched to the distance d1 from the spring unstretched length as shown in a fig. Mean total distance is d1 plus L. So next time t is equal to t by t equal to, the rod is spinning such that blocks move in a circular path at the constant tangential velocity v2. The spring is stretched to the distance d2 from the spring unstretched length where d2 is greater than d1. Mean this is a greater distance as compared to this one. Okay. On the following dot, which represent the block at its location shown in a fig 1, fig 2, draw the forces that exerted on a block spring at the time t1, t2. The spring force must be represented by the distinct arrow acting on and pointing away from the dot. Okay. Now what's the draw the relative length of the vector reflect the relative magnitude of the forces exerted by the spring at both times. So what happened at t is equal to t1? There is a force I identify which cover into three blocks, and that at time t is equal to t2 I draw the force which cover four blocks. Why? Because from Hooke's law, F is equal to K naught X at time t is equal to 1, stretch is d1, F1 is equal to K naught d1. At time is equal to t2, stretch is d2, force is F2, K naught d2. Mean forces are not similar. From the question, we have come to know D2 is greater than D1. So in that case, it's mean this force is greater because D2 is greater as compared to D1. So that's why I have marked that D2 force is greater. Okay. Referring the D1, D2, describe your reasoning for drawing the arrow lengths as do it in part way. Length of the force vector represents the magnitude of spring force. Hooke's law states that the force exerted on spring is directly proportional to the displacement from the equilibrium. Because the stretch D2 is greater than D1, spring exert a force F at t is equal to 2, requiring the longer arrow. So that's the reason here is that you can see longer arrow. Now, is the tangential velocity v1 of the block at time t1 greater than, less than, equal to the tangential velocity v2 of the block at the time t is equal to t2? We have to provide which one is the correct one. So justify your answer without using the equation. So answer is v2 is greater than v1. Now why? Yeah, v1 is less than v2, vice versa you can say. Justification: spring force provide the centripetal force necessary to keep the block in moving in a circle. At time t is equal to 2, spring is stretched more, meaning it's pulling with the more force than t1. So additionally at t2, block is the furthest from the center L plus d2 than the t1 L plus d1. From circular motion, larger radius need a larger centripetal force to maintain the motion. To achieve this larger centripetal force, tangential velocity of the block must increase. Hence, d2, when d2 is greater than d1, v2 is greater than v1. So that's the reason. Uh, the answer is v2 is greater than v1. Now consider the scenario where the block travel in a circular path where the spring is stretched a distance d from its unstretched length L. Determine an expression for the magnitude of net force F net exerted on a block. Express your answer in terms of m naught, k naught, L, d and the fundamental constant as appropriate. The block is moving in a circular path. The only force acting on a horizontal force toward the center is from the spring. There is no friction, no vertical effect, gravity, or because we are moving in a horizontal circle. So net force on a block is just the spring force. So F net is equal to K naught D. That's the only force that's acting on a block. Drive the equation for the tangential speed of the block. Express your answer in terms of m naught, k naught, L, and D fundamental constant as appropriate. For the circular motion, net inward force is equal to the centripetal force, which is provided by the spring force. So F spring force is K naught D. Centripetal force is Fc is equal to mv square by r. But at the distance from the axis of rotation L plus D, D is a stretch. So F net is equal to Fc. We equate both equation. K naught D is equal to m naught v square plus k plus LD. We only require velocity, so we place here all of the remaining factor move another side to, because v is square, so we take square root on both sides. V is equal to square root k naught D into L plus D over m naught. Okay. Does your equation, the tangential speed block of the block in part B to agree with your reasoning in a part A? Yes or no? The answer is yes. We got the equation of the velocity v is equal to square on k naught d L plus d over m naught. So we can say that the velocity is proportional best d in square root d L plus d. When d increases or L plus d as a whole increases, the whole factor increases, velocity increases. The expression v shows it depend upon the d through the product of d L plus d into L plus d. Since both d and L plus d increases, so v increases with the d. Therefore, d2 is greater than v1, d1, v2 should be greater than v1, consistent with the conclusion in a part A3. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly share it with your friends and subscribe it. Okay, take care.